Hello, it's SMTConnect in Nuremberg, day one. I'm joined by Dr Zaki Ahmed from Pulsiv. Thanks for coming over.
Thank you.
What are your first impressions of the show, actually?
Oh, it's been a really good show. There's been a lot of interest in what we're doing,
Good, yeah.
and there's so many new things to see over here. So yeah, it's been
Good,
brilliant.
yeah. And actually, this is one of the first times we've spoken, so actually, can you give me a quick overview of what Pulsiv is about?
Okay, so Pulsiv is a spin-out company from a UK university, and we're here showcasing one of the technologies that we've very recently launched. It's a technology we've called osmium.
Right.
It's used in AC to DC conversion, and it offers a lot of unique elements which we are hoping to bring to the attention of the wider market.
Right, yeah. So is this what we're looking at here? Or?
Yes,
Yeah.
I can show you a little bit of what we
Yeah.
have. So this is a development system that we've put together just to showcase what the technology does. Our technology is actually embedded in a very small device, a little microprocessor. You need a good camera to see this 4mm by 4mm little black box. But that is what implements our unique IP and protects it.
Okay.
And what the device effectively does is it provides a different way of doing something called power factor correction. The core function of the device is to improve the power factor of the power supply, so it achieves over 90% power factor, typically 93 to 95% power factor, which is good enough. And it also provides additional functionality, details of which are on our website, which I wouldn't go into too much detail. The technology produces a different way of doing power factor correction, as I mentioned earlier, and the key outcome of that has been the efficiency of the front end of the power factor correction is consistently very high.
Right.
So this unit on its own has an efficiency which goes from 90% at 2 watts, and it stays high over 95% up to 150 watts.
Right. Yeah.
So if you imagine 2 watts to 150, that's from almost 1% to 100% of the load, where you have a nice flat efficiency profile, which is unique.
So I think people are quite excited about that.
Yes, especially as regulations are now forcing us to think about what's happening at the lower power end.
Yes, yeah.
So this provides you with a very cost-effective way of achieving high efficiency even at low powers, which has gotten a lot of people very excited.
Yeah, and these sort of shows are ideal to be able to talk to people about those things, aren't they?
Yes, we've had a lot of interest because you can use this technology with cheaper flyback technologies to produce effectively something like a USB-C power supply very cost effectively, which has gotten a lot of people very interested, because if you can make something better and it's cheaper, then that's a win-win.
So you said it originated out of one of the universities in the UK?
Yes. So I was an academic at Plymouth University.
Right.
And I originally started off looking at technologies to increase the energy output from solar panels.
Right.
But what I wanted to do with solar panels, you couldn't do with existing circuits. So I invented new techniques, new circuits, and new algorithms. And this is actually a consequence of that work. If you think about it, a solar panel has DC on one side and AC on the other. If you flip it around and you have AC on one side and DC on the other, then that is a power supply. So there's a lot of synergy between what happens in a solar inverter with what you would do in a power supply, and that's what we've used to come up with the first product, which is the AC to DC
Fantastic, yeah.
power supply. Yes.
So was it a little bit of a change in thinking coming from academia to
It was,
this
yes.
commercial world?
Yes,
Yeah.
yes. I think, it's really exciting, watching something go from the research laboratory in academia all the way to commercialization in the real world. And that's been really interesting and fascinating.
Yeah.
There's so many things which are not taught in university, which you learn interacting in the real world.
And don't you think, I mean, we keep talking about a skills gap and needing more people kind of thing. It's those partnerships that this industry is a bit strange, isn't it? Electronics manufacturing in this specific niche that we're in, it's almost a bit of an invisible, it's almost like the biggest cottage industry out there, isn't it? A lot of people don't know it exists.
Yeah, we take power for granted.
Yeah.
And I think that is one of the reasons why it's a hidden world, but there are so many elements that need to come together and actually work properly in order for you to be able to charge your phone quickly or to watch TV or, if you just look around you, the consumer electronics around you, all that electrical conversion needs to happen efficiently, cost effectively, and these are two conflicting requirements.
But I mean, what a brilliant area to be in, because it's only the demands for this kind of thing are only going to grow, aren't they?
Yes, no, absolutely. I think this is an area that is going to expand, and I think some of the regulation coming in, like the USB-C requirement, that is going to help consolidate the industry.
Yeah.
Because at the moment, I think it's a really good move going away from all the different types of cables and power supplies and unifying it and just having one. So you'd have one power supply for your phone, for your tablet, for your laptop, for your monitor. I think that is definitely the best way to go forward, because not only do you reduce clutter, but you also reduce a lot of the unnecessary waste.
Well, sustainability. It's one of those things, isn't it, where the proprietary systems have always been there for monetary returns, haven't they? It's because you have to buy the charger with it, and if we then change our model to have a different socket, you've got to have a different charger kind of thing. So you're constantly selling that kind of thing, which that isn't sustainable, is it?
No. And I think the cultural change from the consumers as well is really welcome, as well as the manufacturers and legislation. I mean, manufacturers, I don't think wanted that, but getting the legislation through to something that everybody recognizes as being better for the environment, better in general, has been, I think, long overdue. But it is great to see, legislation actually moving in the right direction.
Yes, for once, it is good. But when you you must you consider the millions of chargers and chargers that have power supplies that have been thrown into landfill over the past decade. It's
just horrifying to think what's happened in the past. But we have a brighter future, and I think this is definitely a move in the right direction.
That's fantastic.
And bringing new technologies through which support that. So being able to produce a more reliable, a more robust power supply, which can do more. It has many more features. I mean, one of the things I haven't mentioned is, because of the way this power supply is put together, you eliminate things like inrush current. So that's no longer it doesn't occur anymore with this particular front end. Whereas,
so will that increase the lifespan of that unit as well, because it's not having to deal with those fluctuations or pressures on it?
Exactly. So every time you connect a conventional power supply, you might see a little spark. and that is the inrush current going in, and that can't be good for anything inside. I mean, repeatedly, you might be able to engineer your power supply to cope with that, but surely, if you're looking for a long-term solution, a great big spark like that ever so often can't be healthy. It's not healthy for the power supply, and it's actually not healthy for the grid as well. And as the grid becomes more and more diverse, it is actually harder to manage. And constantly yanking sparks out of the grid just can't be good.
No.
So this does eliminate inrush current. So when you plug a power supply based on the osmium technology, you do not get inrush, because by definition there is no inrush, which is a very unique thing to say about it, which is a happy accident as far as the technology is concerned, but who wouldn't want it?
Yes.
If you get it for free, why not?
Exactly, yeah. Well, that's fantastic. It's a pleasure to meet you, Dr. Ahmed.
Yes.
Thanks for sparing the time to talk to us. And I hope the show should be very successful for you, I'm sure.
Thank you very much. I look forward to the show.
Thank you.